Welcome to my video for Management Decision and Control Paper 10 CPA. This is your tutor, Senior Huntington. Now, in today's video, I'll talk about linear programming and I'll use the August 2023 question paper. There is something about linear programming, and it's what I'll use in this video. Remember, linear programming is a mathematical technique to optimize the allocation of the scarce resources. Okay, don't forget that. And of course, many management decisions are essentially resource allocation decisions, and linear programming enables optimal solutions to be found to a range of problems where the number of factors involved and their relationship would make simpler solution methods difficult, if not possible. So it can be used for a range of problems, and the typical applications include the product mix problems, production planning. We can use it in capital rationing and aspects of financial modeling. It's an important technique for the management accountant because it provides an extension of CVP analysis capable of dealing with the practical problems which, because of the large number of interactions and the presence of more than one binding constraint, cannot be solved by the more basic approaches. Remember, this technique can be used to optimize the value of some objective. For example, to maximize the contribution, but when the factors involved are subject to some constraints or limitations. In this video, I'm going to show you how we can use the linear programming technique, how we can use the Simplex method. So just get the August 2023 question paper, then you move to question 2, that is section B of that question paper. So we're on question 2 of section B of the August 2023 question paper. Remember, this is Senior Huntington. Don't forget to subscribe to my YouTube channel. Don't forget to comment. In case you have a question, please, you can post it in the comment section. Don't forget to share. Don't forget to like. Question 2. Modern Constructions Limited deals in landscaping and production of the various concrete products. The concrete products produced include pavers. So we have the products, we have the pavers. So we have the pavers, we have the curbstones, and then the U-shaped culverts. Now these are the products this MCL is producing. MCL's clientele is based in Mbarara City and the surrounding districts. MCL is currently facing low sales turnover due to limitation of material supplies. Coupled with the poor communication and customer care. The poor communication process has already caused operational inefficiencies. MCL produces all the products in batches. So they produce all the products in batches. What are the products? That is the pavers, the curbstones, as well as the U-shaped culverts. So they produce them in batches. The raw materials for these concrete products include cement, stone dust, lime, and sand. The following materials are used to produce each batch of the respective products. So they are giving us the products and then the materials that are needed to to produce a batch of each of the different products. So that is your table. You need 10 bags of cement to produce a batch of pavers. You need 10 bags of stone dust to produce a batch of pavers. You need 20 bags of lime to produce a batch of pavers. You need 50 heaps of sand to produce a batch of pavers. So those are the materials that are used to produce each batch of the respective products, that is pavers, curbstones, and then the U-shaped culverts. Now the cement, stone dust, lime, and sand are purchased at 40,000 per bag, shillings 5,000 per bag, 35,000 per bag, and shillings 50,000 per heap, respectively. The other production costs per batch amount to shillings 3.3, attributable to each product in a ratio of 1 to 1 to 1. The batch of pavers, curbstones, and U-shaped culverts is sold at shillings 4,900, 4,960,000, 4,450,000, and shillings 4,460,000 respectively. Those are the selling price of each batch of these three different products. MCL can only access 12,000 bags of cement, 20,000 bags of stone dust, 22,000 bags of lime per month. Sand is always readily available. So if sand is readily available, then sand is not a constraint. Yes, it's a resource, but it's not a resource constraint. Why? Because it's always available. There is no any limitation for sand. Now CPA Chipanga, a consultant statistician, was engaged to advise MCL directors on optimum production mix, product mix that will maximize the contribution. He used the Simplex method to come up with the final W below. So this is the final W, as you can see. That is your final W. Now where PK and U represent the number of batches of pavers, curbstones, and then the U-shaped culverts, respectively, and then S1, S2, and S3 represents the slack variables for cement, stone dust, lime, respectively. C represents the contribution in thousands of shillings required. Formulate the initial Simplex W. Interpret the final W to MCL's directors. So that is the question. Now these questions of Simplex method, if you've prepared yourself well for such, you can easily score your full marks. And in this question, it's just a matter of coming up with the initial Simplex W as well as interpreting the final Simplex W which has been produced in the question. This is an easy one. I'm going to show you how to come up with the initial Simplex W and then how do we do the interpretation. Share with your friends because I believe any student who is doing MDC needs to learn this. Now, when it comes to formulating the initial Simplex W, formulating the initial Simplex W, that's the first thing I'm going to show you how to do. So formulate the initial Simplex W. Formulate the initial Simplex W. Now, when it comes to formulating the initial Simplex W, the first thing always to work on is to express the problem in the standardized manner, as I'm going to show you. So we start with expressing the problem in the standardized manner. How do we do that? The first thing you have to do is to define the variables. So we start by defining the variables. Remember, in this question, you have 3 different products. So you say define the variables, i.e. I'll say let P equals to the number of batches of pavers. Let K equals to the number of batches of curbstones. To be produced and sold. Then let U equals to the number of batches of U-shaped culverts. So I have defined my variables. So when you see P, just know that it represents the number of batches of the pavers to be produced and sold. When you see K, just know that I'm looking at the number of batches of curbstones. When you see U, number of batches of U-shaped culverts. So I've defined the variables. Now the next thing I'm going to do, I have to come up with the objective function. We have to come up with the objective function. This is the function to be maximized. This is the function to be maximized. Make sure you have the question on your table, please. The objective function is the function to be maximized. When you look at the question, they have told you that CPH Panga, a consultation statistician, was engaged to advise MCL's directors on the optimum production plan that maximizes contribution. Therefore, the objective function of MCL is to maximize contribution represented by capital C. But how do we get the contribution? The contribution has not been given to you. You have to calculate the contribution yourself. You have to calculate the contribution yourself. How do you get contribution? Remember, contribution equals to the selling price minus the variable costs that are incurred. So let us get the contribution per unit. So this is the working. This is a working. I want to show you how do you arrive at the contribution. This is our working for the contribution per unit. It's a working for contribution per unit. That is our working. Remember, we have 3 different products. We have the pavers. I told you we shall use the letter P to represent the number of batches to be produced for pavers. So we have pavers, we have K, that is curbstones, and then we have the U, which stands for the U-shaped culverts. So these are my different products. I want to get the contribution per batch for each of these three different products. The contributions per batch. Want to get the contribution per batch. How would we get contribution? To get contribution, we get the selling price per batch. Selling price per batch. The batch of pavers, curbstones, and U-shaped culverts is sold at, this is 4,960,000. For K, it is 4,450,000. Then for U, it is 4,460,000. That is the selling price per batch. But I'll have to less the variable costs. I have to less the variable costs. When it comes to the variable costs, we need the material costs. We need to come up with the material costs. So materials, when it comes to the materials, we have different types of materials. We have cement. We need cement. We need the stone dust. Then you also need lime. Being that we also need lime. Being that now lime, do we have sand? Yes, we also need sand, because we have been told that a heap of sand is 50. A heap of sand is also 50,000. So sand is another material which we need. So now let us compute. So for the cement, to produce a batch of pavers, I need 10 bags of cement. But each bag of cement, we have been told that it's purchased at 40,000 per bag. So that gives us 400,000. Then for K, you need 10 times still 40,000. Then for U, we need 20 bags of cement per batch, and each bag is 40,000, giving us 800,000. But we still need stone dust to produce a batch of each product. For the stone dust, here we need 10 bags, and each bag of stone dust is 5,000. Then for the curbstones, stone dust, we need 20, and each bag of stone dust, we have seen that it's at 5,000. Then for the U-shaped culverts, when it comes to the stone dust, we need 10 times 5,000, giving us 50,000. Lime, when it comes to lime, we need 20 bags of lime to produce a batch of pavers, and each bag of lime is 35,000, giving us that. Then for the curbstones, we need 10 bags. We need 10 bags of lime, but each bag, we have seen that it's 35,000. Then for the U-shaped, you need 10 bags times 35,000 per bag. Then we move to the sand. When it comes to sand, you need 50 heaps to produce a batch of pavers, but each heap is 50,000. Then for the curbstones, you need 45 heaps, but each heap is 50,000. Then for the U-shaped culverts, you need 40 heaps, and we see that each heap is 50,000. That is 2 million. Those are the materials, but then of course we also have some other variable production costs. We have some other variable production costs per batch, and this amounts to 3.3 attributable to each product in a ratio of 1 to 1 to 1. So here you just get 1 divided by 3, then times the 3.33, that is 3.3 millions. Which gives you 1.1. Gives us 1.1. So now we can arrive at our contribution per batch. I can get the total variable costs. Total variable costs per batch. Total variable costs per batch. So you add all these costs, the direct materials and the other variable production costs, then you get the total variable cost per batch. To get contribution, we get our selling price minus the total variable cost per batch. So these are our contribution. So this is the contribution per batch. That is the contribution per batch which you need in the objective function. That is your contribution per batch, which now you can take to the objective function. For that, you have to come up with a working. You have to come up with a working for that. So let me take this to my objective function. So the objective function, we have said that it is to maximize contribution, which is of course I will leave out the 3 zeros, so I will say which is 210p. Remember, p represents the number of batches of pavers, then plus 250k, then plus 160u. But of course, these contributions are in shillings a thousands. That is my objective function. We are expressing the problem in a standardized manner. I've defined the variables. The objective function is there. Now what next? Yes, however much I want to maximize contribution, but this is subject. It is subject to constraints. It is subject to constraints. What are the constraints? Let us look at the materials that are used to produce each batch of the respective products. From that table, we can arrive at the different constraints from this table. This is the table we are going to use to come up with our constraints. So I'll use this table as well as this information in this paragraph, the limitations. Okay, so that's what I'll use to come up with the constraints, the table, and then the paragraph down there. So subject to what? Subject to 20, it's 20, subject to 10p plus 10k plus 20u, but less or equal. We have been told that MCL can only access 12,000 bags of cement, less or equal to 12,000 bags of cement. Now we call this the cement constraint. That is your cement constraint. Then we have 10p plus 20k plus 10u less or equal to, this is stony dust. Stone dust bags are available, that is 20,000 bags. This is the stone dust constraint. Then the other constraint is that of lime. When it comes to lime, we have 20p plus 10k plus 10u less or equal to 22,000 bags. 22,000 bags of lime per month. This is the lime that is the lime constraint. That is the lime constraint. But of course, there is also what we call the non-negative constraint. The non-negativity constraint. So okay. I can say that this is P, K, and U. These can be the number of batches to be produced for PK and U can be greater or equal to 0. And this constraint is known as the non-negativity constraint. In other words, in this case, it means that the minimum you can produce for K, P, and U is a 0, but you cannot produce less than 0. So here we have expressed the problem in a standardized manner. But remember, in the question, you're required to formulate what we call the initial simplex W. Now, after expressing the problem in a standardized manner, before you come up with your initial simplex W, we introduce what we call the slack variables. Okay, so we have to change the inequalities in the constraints. Change the inequalities in the constraints into equalities by adding a slack. By adding a slack variable in each constraint. Now the key term here is a slack variable. That is the key term. Now a slack variable, this is an additional variable that is introduced to a linear constraint of a linear program to transform them from inequality constraint to the equality constraint. You see, when you look at these constraints up here, they have inequalities, as you can see. They have these inequalities. There is this. There is this. And there is this. I have to change these to equal signs, to equalities. But to do that, I'll add what we call a slack variable to each and every constraint. Now, when it comes to a slack variable, as I've told you, slack variables represent the spare capacity in the constraints. They represent the spare capacity in the constraints. So if you are to add the slack variables to each and every constraint, then we are going to come up with our full formation, which has the constraints with slack variables. So I will say that the full formulation with the slack variables is as follows. We said we maximize our contribution, which is that was 210p plus 250k plus 160u. That was our objective function, but subject to what? Subject to our constraints. Let us look at the constraints. Subject to is my question paper. Subject to 10p plus 10k plus 20u, but then we say plus S1 equaling to 12,000. Then we also have 10p plus 20k plus 10u plus S2 equaling to 20,000. Then I have 20p plus 10k plus 10u, then plus S3 equaling to 22,000. Now that is our full formulation with slack variables. Okay, with the slack variables. So here you see S1, S2, and S3. Those are slack variables, and they represent the spare capacity in the limitations. Now, after coming up with your formulation with the slack variables, then you can finally come up with your initial simplex W as required by the examiner. So this is my initial simplex W. We are going to come up with the initial simplex W. So in the initial simplex W, we have a column for solution variable. We have a column for the basic variables, or you can call them the products. The products, those are the variables that are non-negative in terms of the optimal solution. So we have the products, then we have the slack variables, then you also have the solution quantity. We also have the solution quantity. The products, of course, as you know, we have 3 different products. My products I have we have P, there is P, there is K, and U, the U-shaped culverts. Then for the slack variables, as you have seen, we have S1, we have S2, and S3. Those are the different slack variables which we have. So when it comes to the solutions variable, these are the values of a decision variable in the solution to a linear programming problem. So here we have our S1, we have S2, I have S3. Then I'll also bring the contribution. I'll also bring in the contribution. Now what we are going to do, we are going to get this full formulation with the slack variables. Then we enter it in the initial simplex W. We enter it in the initial simplex, W. So when it comes to S1, remember S1 that represents your S1 represents what? S1 represents your cement constraints. So for S1, for pavers, to produce a batch of pavers, I need 10 bags of 10 bags of cement. I need 10 bags of cement to produce a batch of curbstones. Then I also need 20 bags of cement to produce a U-shaped culvert. Now the simplex method, of course, automatically assigns a value to the slack variable. It automatically assigns a value to the slack what? To the slack variables. That contains, so each column of the slack variables contain a single figure 1, with the rest of the columns being zeros. And when it comes to the simplex W, the solution value for a variable is always found opposite the figure 1, where the rest of the columns are, 0. So what I'll do, I will add a single figure 1 with the rest of the columns being zeros. But remember, when it comes to the cement constraints, our bags of cement are limited to 12,000 bags. So I put 12,000 bags there. We move to S2. When it comes to S2, still under S2, that is the stone dust constraint. So here we need 10 bags of the stony dust to produce a batch of P. Then we need 10 bags to produce the U-shaped culverts. But then this will be a 0, S21, and then a 0. But our bags of stony dust are limited to 20,000 bags. So we put 20,000 there. We are creating the initial simplex W, don't forget. We move to S3. S3, that is the line constraint. We need 20 bags of lime to produce a batch of P, 10, 10, 0, 0, 1, and our bags of lime are limited to 22,000 bags. Then from there, of course, you have to go and bring in your contribution. That is 210, 250, and then 160. So contribution, remember your contribution is in shillings or thousands. So here I have 210, I have a 250 and then a 160 and then a 1 and then a 160. So when it comes to zero production, of course we have a nil contribution. So your contribution will be nil at zero production. And then of course the maximum unused capacity as represented by the values in the slack variables. When it comes to the slack variables, these will be 0. Okay, those will be 0. The maximum unused capacity as represented. So we have zeros when it comes to the columns of the slack variables in the contribution row. So ladies and gentlemen, that is your initial simplex W. And according to the question, that carried around 80 marks. So that's how you come up with the initial simplex W. If you have a question, please, you can share it in the comments section. Now, I'm going to show you how to interpret. Interpreting is very, very easy, as you're going to see. So, he used the simplex method to come up with the final W below. This is your final W below. And you're required to interpret the final W to MCL's directors. So, we are going to interpret. I'm going to show you how to interpret that table. Don't forget, this question paper should be on your table. For us to move well, for you to be following, you should be having the question paper on your table. But don't forget to subscribe, don't forget to share, don't forget to comment, and don't forget to like. This is your tutor, Senior Hannington. For those who are planning to set the MDC paper, you can contact me. My contacts are on my YouTube channel. You can contact me for more inquiry about my lectures and then about my revision kits. I believe the revision kits are very, very excellent because they are exam focused. Now, how do we interpret? This is your table. That is your final W. So we are going to interpret. When you look at that table, you'll see that the contribution row, this is your contribution row. The contribution row of the final simplex W contains only negative items. Now, what does that signify? It signifies that the optimal solution has been reached. Remember, P represents the number of batches for pavers. K represents the number of batches for culverts. So I have P in my solutions variable column. At the same time, I have K. But we look at your right hand side, the solution quantity. You see we have 400. And then you also have 800. Now, what does that mean? It means that this final W, the solution quantity column for any product listed on the right hand side of the table, in fact listed on the left hand side of the table, indicates the quantities of the products. The solutions quantity, which we see the 400 and the 800 for any product. Now the products are listed on the left, but the solutions quantity are listed on your right. So the solution quantity column for any product that is listed on the right hand side of the table indicates the quantities of the products to be produced when the optimum solution is reached. Therefore, at the optimal solution, MCL is going to produce 400 batches of pavers and 800 batches of curbstones. U-shaped culverts are not going to be produced because there is no any equation for the U-shaped culverts on the left hand side of our table. But of course, you have to put this in writing. So let us see now how to interpret. Let me do the interpretation here. interpretation. Interpretation of the final W. I'm going to show you how you're supposed to present this during the exams. So the first thing I'll look at are the quantities to be produced. When you're interpreting, you have to talk about the quantities to be produced. So we have seen that as per the final W, the optimal solution is reached at when what? When 400 batches, okay? When 400 batches of pavers, and 800 batches of curbstones are produced. So those are the quantities to be produced. So at the optimal solution, or at optimality, 400 batches of pavers and 800 batches of curbstones are to be produced. As you can see, PK 400, then 800. Of course, you can say that no batches of U-shaped. I'll talk about that. No batches of U-shaped. No batches of U-shaped culverts. To be produced. No batches of U-shaped culverts to be produced because there is no equation for it. That is quantities to be produced, so we have talked about that. Now the other thing which we have to talk about is the maximum contribution. Talk about the maximum contribution at the optimal solution. Talk about the maximum contribution at the optimal solution. Now look at the contribution row. This is the contribution row, and the solution quantities shows our contribution of 284. But remember, this is in thousands. This is in shillings, thousands. So it is 284 millions. This is your contribution at the optimal solution. So the maximum contribution at optimal solution equals to shillings 284. That is your maximum contribution. Okay, that is your maximum contribution. Okay, this is shillings for 284 millions and from the above number of batches, from the above number of batches shown from the above number of batches, i.e. we have seen that we have P, that is pavers. Pavers, we are to produce 400 batches. 400 batches, but each batch MCL earns a contribution of 210,000. So 400 batches times 210,000, that equals to how much? That equals to 84 millions. That equals to 84 millions. Then we also have K, the culverts. Culverts, our quantity to be produced at the optimal solution, that is 800 batches as shown above, but each batch the company earns a contribution of 250,000. Check your working for the contributions. Each batch of K gives us 250,000, and when you multiply you get 200 millions. Get 200 millions. Therefore, your total contribution. Now, this is just to check the optimum production by the product contribution. Okay, so your total contribution equals to shillings 284 millions. So this is just a check, but your final W shows that the contribution at the optimal solution is 284 millions. Remember, this contribution is in shillings 1,000, so there are some extra 3 zeros to add. So you have to talk about that when you're interpreting, as you can see there. Quantities to be produced, the maximum contribution at the optimal solution. Then what else can we talk about? We can talk about the unused bags of raw materials. But I can take you to the question to show you that the unused bags of raw materials. Remember, when it comes to the solution variable that is on your left, you have S3. S3, that is the slack variable that was added to the lime constraint. So S3 represents lime. S3 represents lime. So if you have S3 here on our left on the solutions variable, and you also have a figure on our right hand side of the table, the 60,000. Now this represents the unused bags of lime. 6,000 represents the unused bags of lime at the optimal solution. So also talk about that. Talk about that in your interpretation. So let's talk about that in our interpretation. That is unused bags of raw materials. In brackets, I'll talk about S3 in particular. I'll talk about S3 in particular. Then I can say that the final, of course I have to write about that. I have to write about that. This is how you're supposed to interpret. This is how you're supposed to interpret. So I will say that the final simplex therefore, okay, the final simplex indicates that the optimal plan indicates that the optimal plan will result in 6,000 unused bags of lime. Result in 6,000 unused bags of lime. We can prove this. I can say that the number of bags required in the optimal solution are, remember, according to our optimal solution, we are producing 400 batches of pavers, but we have already seen that each batch of pavers requires 20 bags. Requires 20 bags. Then we have also seen that we need to produce 800 batches of culverts, and 800 bags of 800 batches of curbstones, and each batch of curbstones requires 10 bags. Of lime. For U-shaped culverts, there is no production for that as per the optimal solution. So when you multiply and you add, you get 16,000 bags. Now those are the bags that are required in the optimal solution. Those are the bags that are required in the optimal solution. Those are the bags that are required in the optimal solution. But remember, the total bags that are available are 22,000 bags. Don't forget that. The total bags of lime are 22,000 bags. Now, if out of the 20,000 bags we have used the 16,000 bags, therefore resulting in 60,000 bags unused, therefore resulting in 6,000 bags and 6,000 bags unused. That is 22,000 bags minus the 16,000 bags that have been used in the optimal solution. That is the unused bags of raw materials, and we can see that from our final tableau. S3, this represents lime constraint, and your right hand side shows that the 6,000 bags were unused. The other thing which we have to talk about when you're interpreting are the shadow prices. The other thing which we have to talk about when you're interpreting are the shadow prices. Don't forget to talk about the shadow prices when interpreting. So let us talk about the shadow prices and then we can stop there. Though there can also be some other things to talk about when it comes to interpretation, but sometimes because of the limited examination time, you may not be able to go into deep analysis of that final table, but at least there are some points which are very vital when it comes to the interpretation. The unused resources, the maximum contribution, the quantities to be produced, and then maybe also have to talk about the shadow prices. So shadow prices. Now, how do we come up with the shadow prices, or where do you find the shadow prices in the final W? You see here you have your slack variables S1, you have slack variables S2, as well as the slack variable S3. Now you look at the contribution row of those columns. Here there is a 17 negative, here there is a 4,000, here there is a 0. Now for S3 that is lime, there is no any slack variable for lime. Why? Because lime, we have 6,000 bags of lime that are unused. Slack variables are for those constraints or for those resources that have been fully utilized. Rather, the shadow prices are for those constraints that have been fully utilized when it comes to the optimal solution. But look at the lime, that is S3. S3, we have 6,000 unused bags of S3. So there is no shadow price for, there is no any shadow price for what? There is no any shadow price for S3, that is lime. But for S2, which is cement and stone dust, there is no any equation for them on the left hand side. That is the solution variable. There is no any equation for S1 and S2, meaning that they have been fully utilized at the optimal and the optimal solution. So the shadow price is for those resources. It will exist for those resources that have been fully utilized at the optimal and the optimal solution. So we have to talk about the shadow prices. I'll say that the fact that there is no equation for, please look at the question, look at that final table. The fact that there is no equation for S1 and the S2 means that these are inputs, means that these are inputs that are fully utilized. Means that these are resources that are fully utilized, and that limit further increases in output and profits. that limit further increases in output and the profits. Now let us see the shadow prices. There is 17,000. Remember the contribution raised in shillings are thousands. So we have a 17,000 for S1. We have a 17,000 for S what? We have a 17,000 for S1. So let me talk about that 17,000. So I'll say shillings. Shillings 17,000. Shillings 17,000. Shillings 17,000. This is the shadow price. That is the shadow price of cement. That is the shadow price of cement. That is S. That is S1. That is the shadow price of cement S1. So if I want it right. If an additional bag of cement, okay. If an additional bag of cement, yeah, if an additional bag of cement can be obtained, if an additional bag of cement can be obtained, contribution will increase. Contribution will increase by shilling 16. Sorry, by shilling 17,000. Yeah, contribution will increase by shilling 17. By shilling 17,000. So the shadow price of cement is 17,000. And after that, if an additional bag of cement can be obtained, then contribution will increase by shilling 17,000. A shadow price, that is the increase in contribution as a result of introducing an extra unit of a scarce resource. Now we look at this final Simplex W. The moment you introduce an additional bag of cement, S1 column, the moment you introduce an additional bag of cement, it will increase the output of pavers by 0.2. It will increase the output of pavers by 0. What? By 0.2. It will increase the output of pavers by 0. What? By 0.2. It will increase the output of pavers by 0. What? By 0.2. So if I have a 0.2 batches, I have 0.2 batches of pavers increase, and we know below that on each batch we earn 210,000 contribution. Then if you introduce that additional stack of that additional bag of cement, I've told that it will increase output of pavers, that is by 0.2. So this is a positive, but then it will decrease the output of curbstones by 0.1 batches. So when I get 0.1 times on a batch of curbstone, the company earns a contribution of 250. So when I get 0.2 batches at 210 minus 0.1 times 210, I'll come up with shillings 17,000. So this is the shadow price. That is the shadow price of cement. That is the shadow price of what? That is the shadow price of cement. Still, there is also need to talk about the 4,000. Don't forget. You also have to talk about We also have to talk about the shillings 4,000. Only that my pen is misbehaving. I don't want to do more writing. It's misbehaving. Talk about the shillings for. Talk about the shillings 4,000, which is the shadow price of Stony Dust. Shadow price of stone. Shadow price of Stony Dust, that is S2. My pen is misbehaving. I'm going to stop here. Shadow price of Stony Dust S2. Hey. So if you introduce an additional bag of Stony Dust, then contribution will increase by 4. Contribution will increase by 4,000. Let me take you back to the final tab and see. This will be the increase in contribution if you introduce an extra bag of Stony Dust, something which you can also prove. For S3, as I've told you, there is no shadow price. The shadow price is 0 because at optimality there are unused bags of lime of 60,000. So that is how we interpret our final simplex W. Talk about the shadow prices. Talk about the unused bags of the raw materials or unused units of raw materials. Talk about your maximum contribution. Then talk about the quantities to be produced. Let me stop here. In the next video, I'll show you how we can deal with the issues of sensitivity analysis, and then also how to use the graphical approach. I remain your tutor, Senior Huntington. Don't forget to subscribe, share, comment, like. Bye bye.